Okay, good evening and welcome on our first Belgian Developer Experience Network meetup. Just 5 minutes introduction about what we're going to do during this meetup, why this community is there. Maybe first of all, yeah, we have shift left going on, with a lot of responsibilities being pushed towards developers. Again, and as well, some infra ops security stuff as well, but we as software developers don't always focus upon. And then you have the silos in the organizations, being ops, infra, security. You have the business as well. For example, return on investment is important for the business manager, so you can't refactor always to refactor. Where developer experience group will be playing is in this void. We will be bringing topics regarding security, regarding infra, regarding DevOps, but always with developer focus, developer messaging. And this slide is already outdated because I think AI is a silo that's missing over here as well. And then in the end, it's not the purpose that you as a unicorn will be doing everything, but the thing is that you as a developer will know about what's existing so that you can make choices, knowledge choices with what you know that you can rely upon. For example, what's existing in the infra space that you don't have to code it yourself. And then infra ops people can implement this for you. So we don't expect that you will be able to do this all, and just bring awareness. And maybe for this evening, Glenn, you can go to the agenda.
Yeah, so first of all, Martin has already given a small demo. Second of all, we have talk about generative AI. We switch. So second of all, we have the talk about generative AI. Then we will have a short break. It will be normally around 5, I think.
It will be now 5:30.
Yeah, indeed. So it will be around 5:30, small break of 15 minutes. And then after the break, Thomas and me will present a presentation about DevOps, which will actually highlight a bit of the pitfalls that we see around DevOps these days. And then, I think also probably half hour later, so 6:30, around 6:30, we will have some tapas, and we will have a moment to network with each other and to talk about what we learned and which things we would like to discuss with each other. After we had the moment to network and to talk with each other and to grab a bite and drink a bit, we will be able to throw some axes around, and then we will wrap up and finish the event. So yeah, let's get started.
So, the era of app, or as you know what the acronym stands for, AI, augmented programming using modern Java. That's what I want to talk about. This is actually a talk, it's the third time that I'm giving this talk. So it has already, how would I say that, been refactored a bit, been adjusted based on the feedback. I actually gave this talk last week at JFall, where I got some very interesting feedback as well. And then previously I gave it at Thessaloniki. And a talk is like good wine, right? You need to give it a bit of time and it just gets better after a while, after some iterations. And of course, as you know, app, I mean, if you speak Flemish or Dutch, stands for monkey. And the reason why I'm using this acronym is that a lot of people are starting to use generative AI as a replacement for Stack Overflow, where they can just copy and paste what this generative AI suggests without thinking, and then they all of a sudden deploy that in production and things go wrong and so on. And so there's definitely some gotchas. I mean, first of all, please do not just copy and paste what the Gen AI gives you, right? That's the first thing. What's very, very important is that you give it the right context. And actually, I got a response last week that somebody did not know that you could actually pass context to these large language models. And I'll talk and demo this. There's actually, it's not just pure chatting and asking one question. No, it's a lot more than that. But before we do that, as you know or don't know, I mean, I organize, or I'm the founder of Devoxx, and the beauty of organizing an event like Devoxx Belgium is that you get we get 1,000 proposals, and you get a real view of what's hot and what's not within the AI space and in the dev space, etc. And I know, like even Tom as well, and many others, they like to be community reviewers because it's also for them a nice opportunity to see what's alive in the tech industry just by looking at the proposals, right? And I'll come back to that one later on. But the most important thing for me actually is to create this, I call this a cloud, a tag cloud or a keyword cloud. And this is a keyword cloud of all the proposals that we received this year for Devoxx Belgium, which were 900 of them. And what's very exciting to see is that, well, Java is still very dominant because it's I would say more a JVM type of conference, not so much a pure Java conference, because we do Kotlin and Scala and other JVM-related languages as well. But what we saw this year, which was not there last year, was the generative AI keyword, large language models, and LangChain4j. Those were 4 keywords. And by the way, the keywords are generated using ChatGPT, of course, right? I mean, I use what I preach, or I preach what I use. So basically, if somebody submits a title and a subscription, ChatGPT gets the 4 important keywords out of that. But these were not there. And so as a result, from the 220 talks that we had, or 200 plus talks, I think about 25–30% were AI, Gen AI related. So we had a lot of very interesting talks. And by the way, all these talks, we've published them the day after on our YouTube channel, on Devoxx YouTube channel. So if there's another, I'm predicting we're going to have a lot of rainy weekends from now onwards, right? You should just sit, relax, get a beer, and watch some YouTube talks, because there's some really good quality talks that you should have a look at. But the feedback I got last week is that I was immediately jumping straight into the deep with lots of acronyms here and there and new things. And somebody said, like, Stephan, you should start with some terminology first, because not everybody has been doing this Gen AI or AI and so on as long as you have. So the first one is neural network. I mean, we are still talking about neural networks, even if we are talking about Gen AI. And this is a nice, I copied it somewhere from the web, where you see large language models are part of deep learning, machine learning. And it is still using neurons. I mean, it's still using layers of neurons to get to certain results. The most important thing that has changed since 2017, which was the document Attention is All You Need from Google, is the transformer model. So the transformer model allows to process words in relation to each other and to create a semantic meaning of what these words actually represent. So it knows about certain words which could have double meanings, that it knows within the context what that word actually means. Right? So that's like a bank, for example. You know, if I have a bank and all of a sudden I talk about money, you know, it's a bank, it's a financial institution. But if I talk about a bank and a forest, I might be sitting on a bank to relax in a forest. And it actually knows about this using this transformer model and the semantic meaning using vectors. The parameters, these are the model's internal variables. And the parameters is often a reference where if I say, this model has 405 billion parameters, the parameters are actually the internal variables based from the training and the knowledge. These parameters are floats, but that's not always the case, because it could actually be if you quantize, and quantization means that you actually limit, for example, a float from 32 bits to 16 bits to 4 bits to just 1 bit. This is called quantization, where you actually are reducing the meaning of that float vector by reducing the numbers, the digits of that value. And by doing that, by changing, quantizing the parameters, you can actually have smaller models which can just run on your phone or on your portable, you see. So these are the parameters. So the bigger the parameters, the more knowledgeable this model is. The lower the parameters, it might just be a model of like 3 billion, which is still a lot actually, but it will have less knowledge, right? But it could run on your phone. So that's a very important thing that I'll talk about. And I think another one important is the window context. So this is where you talk to a large language model via a chat. Yeah? Like I'll generative AI starts with a chat, this conversation. And what's very important is that what you put in that chat, that's your window context. Now, just to give you an idea, last year, which is the next topic you need to know, are about tokens. So let me first explain tokens. Those are the smallest pieces of text that the large language model understands. Now, a token, one token is not one word. It can be, but often a token represents a portion of a word. And these tokens are actually the subwords, and it gives actually the meaning to the large language model, what it is about. So it's chopping up these sentences in specific tokens. And so when we talk about a large language model, we talk about how many tokens the window context supports, right? So last year, the maximum window context that you could send to an LLM was 4,000 tokens. So 4,000 tokens, roughly, you can multiply that by 3. So one token is, on average, 3 letters, right? So you have like 12,000 letters that you could send to the prompt in one go. How big is the window context today, you think? Yeah, last year, 4,000. You would say maybe double, 8,000, triple? No, 2 million. So from 1 year, we went from 4,000 tokens to 2 million tokens. Now, to give that in perspective, 2 million tokens, do you know how much that is? I've calculated it. It's 3.2 times the Lord of the Rings trilogy. Now, the Lord of the Rings, the 3 books. So that's 9 books, 0.2, that you can include in one prompt. Now, why is that important? Context. I can put my full project in the prompt and then ask questions. A lot of projects that you work on, especially if you're doing microservices and so on, they're already small projects anyway, right? So I can include my full project and then say, find me a security bug. Now, if you just do, hey, I'm doing this open project on GitHub, what are the security problems? And that's your context. It will come up with some stupid answers. Maybe it might even hallucinate. Right? But if you include your full project, not only that, you include the PDFs, you include the latest version of a certain API that has not yet been indexed because it's privately used or something like that, you include that all in that context, it will know how to answer it. And that's just magic. When that happens, you go like, what the F? It really is. So that's a terminology. So don't forget that. That's very important. If you already know those, you can already go in discussion and at least pretend. Then there are 2 very important opportunities. You have local models and you have cloud models. Let's start with the local models. The local models, so basically these X amount of billion of parameters model is just a file often. Often it's a GGUF, it's a universal format file, which includes the tensors and it includes all sorts of data. But we as end users don't have to think about it. You basically download that model and the model can actually run on your local machine. The ones which are often used by developers are the ones from Meta. Meta, Meta, Facebook. So, I mean, Zuckerberg, he's a bit late to the game. Yeah? So what is his strategy? If I can't beat them, I will not join them, but I will just open source it and have the best models out there. So Meta 3.1 is a really good model to have on your local machine, and it just runs locally on Mac, Windows, Linux. And I'll tell you how to run that later on in the next slide. Then there's a newer version, version 3.2. This is not as good as the 3.1, but the 3.2 is also multimodal. So that's a new term. What is multimodal? Multimodal means that it's not only text, but it can also do images and audio. So I can give an image and actually say, what's in this image? And seriously, it is not saying, I see, like my son plays basketball, so I have a snapshot of a game. I give the image of the game. It does not say, I see some players on the court. No, it says, this player is doing a block for that player because he's going to do a reverse. I go, what the hell? It actually knows the place of basketball So I could just feed this like every 5 seconds and ask like, hey, what's going on? And it could actually analyze a game. You can do that. I mean, that could be a startup on its own. Seriously, you could really do that. I might not use Llama 3.2, but there are other ones which are even more sophisticated, which only run in the cloud, right? So, but you have local models. This is very important for developers because you're going to use local models also on your machine if you're disconnected, you have no internet, you're on a train or on a plane or on the toilet and you have no internet, you want to have maybe work with local models. I'm mentioning Qwen 2.5 because that's a new one. It's a Chinese one, but I've been told that the coder version of Qwen 2.5 is also very good, so you might have a look at that. And then you have the providers. So if I've downloaded this model, how do I talk to it? Now, talking to a model is called inference. So you talk to a model, that means you are inferring to the large language model to get an answer, right? So that's inference. But let's just say we'll talk to it. There are 4 big players in the market. Llama is the most interesting one. That's the one on the top, as you can see. I mean, it's all Llama-based. That's a bit the joke going on. But all 3 of them, LM Studio, Llama, and Jan, they use underneath the Llama C++ library. It's an open source project by a Hungarian, very super genius person. I've asked him to come to speak at DevOps multiple times, but he's not interested. And but this is like the Swiss knife, the Swiss army knife. I don't know if you ever did video editing. In video editing, there's only one tool you need to know, which is FFmpeg. This is like, if you do video editing, FFmpeg is the Swiss knife. Well, if you're doing large language models locally, Llama CPP is the one, right? It's, of course, written in C++. Well, all the 3 of those, they actually use that. So that's it. How do you install it? Very easily. Just this evening, instead of watching Netflix, just go to ollama.com/download. It has an executable. It works for Windows, Linux, and Mac. You just go, let me show you. Not now, remind me later. So you do Ollama like this, and it will give you the different options. So if I want to know the models that I've actually already installed, it's a bit small, but maybe bigger. These are the local models that I have installed. And you just start Ollama as a service, and it's basically when you then talk to Ollama, you just say, okay, I'm using this model. And you can see here the sizes of the different models. So I've got models from 4 to 2 gigabyte to 40 gigabyte, right? So and you see the Llama 3.1 latest is 4.7 gigabyte, right? It does help to have a good portable. It's almost Christmas, it's a great excuse, but honey, I need it for my work, right? And there's the new M4 just released, the MacBook Pro M4. It's going to really work very well on that. So I guarantee you do that. Okay, so those are the local models, but then we also have the cloud models. Now, there's a big warning here. If you use a cloud model, they will use your prompts as data for training their models. So that's really important to know. Once you use ChatGPT or Anthropic or Mistral or Google, they will most likely use your data for their new data set. Yeah. And so this is like a big no-no when you're working with government or military or just a startup with intellectual property that you don't want to share, then a cloud model is not the way to go. There are some, of course, on-premise solutions, and that's why I've mentioned it. I mean, I know Patrick Dubois talks about this. You should really invite him because he does more LMOps, not so DevOps. He actually invented the word DevOps, by the way, Patrick Dubois. But he talks about how to deploy ML in the cloud, etc. And so the ones you need to remember, if you only remember one thing from this talk, it's this one. Claude Sonnet 3.5 will change your life. Seriously. No, I'm not kidding. It will change your life. That's the best model today. 3.5, it's Mecca. It's magic. It's voodoo. It's unbelievable good, right? And the crazy thing is, every new version is just getting better than the previous one. So this is the worst it will ever get. It's only getting better. And some already are complaining, yeah, but we are plateauing. But no, it's still scaling. They're still adding more data. It's still getting improved, etc. If you want to have a 2 million window context and you want to send the whole Lord of the Rings 3.2 times, then you have to use Gemini Google, which is the one that has 2 million. In the labs, they already have a version of 10 million tokens. So basically, once you start talking more than 1 million, it's infinity, basically, right? I mean, yeah, that's just unbelievable. And I mean, I had to add Mistral, because Mistral, hey, European, it's a French company who at least has also a bit of interest in AI, which is great. Okay, so that was the introduction. Still one slide that I added. If you do LLM inference, like I said, conversation, what you really need to know is that you start a conversation. It's not just one chat and you forget. No, it has like, people call it a memory. So that means that if I say like, hey, who's Tom Coles? And they say, he runs the BeJUG. And then I say in the next word, did he speak at JFOL? Then did it should know that it's about Tom, because in the previous question I spoke about Tom, right? And so that's the memory. So that's very important, is that these chat models, some of them like ChatGPT just recently has added memory, but they do memory even more than what I'll be explaining, because they can basically memorize everything you've ever said in every chat that you did and so on, right? But this is how it works. You first have a system prompt. In the system prompt, you set the context, you set the tone. So in the system prompt, you might say, hey, so the system prompt goes to the LLM saying what it is about, how it should react. So in the system prompt, you can say, you are a Java expert, you know everything about Spring Boot, and the front end is all in Angular. So that sets the context. That's very important, because if you say you are Brad Pitt, an actor in Hollywood, and you know nothing about coding, it will actually act as Brad Pitt knowing nothing about coding. So it focuses on its neurons, so to speak, because for a lot of people still, they don't know what's going on in these neurons connections. The system prompt is very important to set the tone. And then you have a user prompt. So this is what you enter, right? And then you get a response. And then you do another system prompt. Now a user prompt. The system prompt remains once. You just said it once, and then you have question, answer, question, answer, question, answer, question, answer. And that combination, that's called the chat memory, right? And so when you talk then to an LLM, that's called inference. And you can talk to local, or you can talk to cloud. Cool. So that's the terminology. That was the introduction. I hope you already learned something. But now let's go a bit deeper. I'm not looking at the clock, so I'll just talk and let's have fun, right? So the one that wasn't released or wasn't showing up in the cloud tag from last year was LangChain4j. The beauty of LangChain4j is that it basically got introduced for the very first time at Devoxx Belgium last year. I invited Liz Raas, but I was basically already months before that, I was in collaboration with the head or the person who founded LangChain4j, Dimitro. The problem with Dimitro is very shy. He doesn't like speaking and he doesn't like clouds, but he's a great developer. His code is just poetry. It's just beautiful. And he basically started LangChain4j. And it is a unified Java API to talk to LLMs. Now, to be complete, first thing is, if you use Spring Boot also has Spring AI. So these are the two choices you have as a Java developer. Either you use LangChain4j or you use Spring AI. They're very, very similar. The beauty of LangChain4j, for me, is that it's really a project on its own. It's an independent project that started. The code is just very beautiful. Dimitro is a genius, in my opinion. But also at Devoxx Belgium, he got introduced, the Quarkus guys from Red Hat, they were at his talk, and they went like, I know Dimitris was there, and he was like, what is this? And he was blown away by Liz, her talk on LangChain4j. They sat together. George, he implemented LangChain4j implementation that same day. The next day it was available. 2 weeks later, Quarkus hired Dimitro to work full-time on LangChain4j. And that's like, That's it. I mean, that's where the dots get connected at DevOps. It's like, that's so it's like the butterfly effect of organizing these events. It's like, wow, really beautiful to see these interactions, how it goes. If you want to know more about LangChain4j, just go to the DevOps channel. There's some beautiful talks from Guillaume Laforge and a few others on RAG, for example. I did some talks on RAG in the past as well, but I'm more interested in AI coding assistance. And that's really the meat of this presentation, is that I want to actually show you how you can use AI coding assistance using modern Java. So my ambition is to have AI coding assistance, but fully developed in Java. From beginning till end, full Java stack. Is that possible? How can we do this? And well, first of all, I can say, yes, it's possible. That's already exciting, but it's early days. So just out of interest, who's allowed to use a cloud large language chat model at work? Who's allowed? I see 4 or 5 people. Who is not allowed? More interesting. Wow. So they're just for people who are looking at the street. There are more people not allowed to use it than they are allowed. So, and for good rights, right? So privacy, it's out of the window once you use a cloud model. So if you're using proprietary projects and you want to protect that, yes?
You have these.
Yeah, you have these enterprise. Yeah. And you trust them?
Yeah, but it's in the contract that they.
Yeah, yeah, sure. If you think that's true, and I hope so, then great, you can do that, but be cautious. And there are reasons why certain governments are not doing this at all, because you don't know what's going in that black box.
No.
So just be cautious.
Yeah,
that's what I'm saying.
Following that path of thought, you can start doubting everything. And everything
Yeah, but I do.
Yeah, okay. Fair enough. Yeah.
Don't forget, these are the companies that basically committed worldwide copyright infringement under the guise of we're an NGO. Oh, sorry.
Yeah.
So this is basically the sorts of companies that say, "Oh, we're going to commit worldwide copyright infringement," but it's all fine because we're an NGO that is now going private and
commercialized. Yeah,
and commercialized. So.
Or Google saying we do not do evil, and then what you see they do is, well, it's evil.
I
actually,
think caution is
be
a good
cautious.
approach.
But sure, I mean, if the contract's in place and you have an on-premise installation, I think an on-premise is probably okay because it's running on your servers as a company and you have it really in your gated environment. But just be cautious. OpenAI is so hungry for data, but nowadays data is becoming less trivial because they can create this synthetic data, which is basically the model creating the data for the training, and it's like this loop that it's basically we could extrapolate to singularity point, but that's something for after this with a beer and so on. What I want to mention is that AI will not replace your job. We're still safe. You don't need to have a burnout or the identity crisis. But what I will tell you is that developers using AI will take your job. I'm 100% convinced about that. If you look at how I've been using AI, I'm so much more productive. You do have to be a bit of a senior developer, because if you're a junior developer, it's gonna, I mean, I think, Tom, you did a great talk there last year where you say, oh yeah, let's build a cache framework because that sounds fun. And you go like, what? As a junior developer, okay, so I need to build the cache framework? No, there's a cacheable annotation that you can use, so why do that? So as a senior developer, you need to guide the prompts and the conversation a bit to the direction that you are comfortable with. So you have to watch out. Juniors do not have that knowledge, so they might actually hurt themselves. But a junior developer can now ask the stupidest questions, the dumbest questions, like, you know, RxJS, how does this zip work, and how does... Because it doesn't evaluate you, it doesn't judge you, it will give you the answer and explain it. So I don't believe saying like, oh, but LLMs will create a void where we don't have any senior developers anymore because junior developers are now left behind. I don't agree with that. If you're a junior developer, just ask the damn questions and it will explain it to you in full detail how it works. We have now a universal tutor, which is available for $20 a month. Universal, you just need internet connection. I mean, come on, we should be thankful that this is like, no, am I the only one seeing this? I mean, right? No, so, okay, we all agree. But you have to use AI. as a developer today. No, last year, because you're just gonna miss the train. And so this was last year. I had Anton from JetBrains do a keynote about their AI assistant. Who uses IntelliJ here? Okay, the majority. I would say 90%. For the other ones, probably VS Code, most likely. And so he did the demo of AI Assistant. And at that keynote last year, I asked him, hey, are you going to support local models? And is it open source? And the answer was no. And a month later, I asked, like, oh, what's the status, Anton? What's the status? No, we're not yet doing it. So 3 months later, after Devoxx Belgium have like 4 months to hack and to talk and have fun and so on. And so after 3 months, they're like, okay, I'll do it myself. So I rainy weekends, I built my own plugin. Never built a plugin in before for IntelliJ, so that was already a journey on its own. And I basically developed I wanted to build a fully Java IntelliJ plugin, which eventually would be full Java, so from beginning to end. Now, 1 year ago, that was not yet possible. Today, it actually is. And it's open source, it's free, and that's what IntelliJ doesn't like, because their AI assistant is $8 a month, and mine is actually doing the same thing and better, in my opinion, and I'll talk about that later on. But it's true. But the reason why I'm doing this plugin is not so much I want to not create a company. No, I want to put pressure on IntelliJ, because they have to release this plugin to support local models, have all the cloud models. I basically want to push them. And when I talked about this at Devoxx Belgium this year, last month, Anton told me there were more than 100 people coming to our booth saying, we need local model support. I said, yes, it's working. Yes, because I don't want to build and continue supporting a plugin. It's their job, it's their business, right? But so it's working, and I'll come back to that one later on, but let's first do a quick demo. So if you go into IntelliJ, you all know this, you basically go to plugins, settings. I hope it's good enough, you can read it. So in the plugins, it's actually on the marketplace. So you just go to marketplace, you type in Devoxx, and it will suggest Devoxx Genie. So we already have 5,000 downloads. I'm really proud about that. But again, this is just guerrilla strategy, right? I'm just pushing IntelliJ to do what I would like to have as a developer. So when you install it, once you've installed it, you will see this nice blue, well, not blue, Devoxx logo here. And there, you can click on this cog sign. And on that sign, you can actually specify the local models you want to use or the API keys of all the cloud models. Yeah. So that's pretty standard, which is great. So the ones you only need is the one from Anthropic Cloud, right? Sonnet 3.5. That's the one you want, right? So you just get that one. And then you have the LM settings, a bit of different settings that you can specify. The important one is here, the prompt. So that's the prompt I'm using. You're a Java expert that knows everything about open LLM in interfaces. And then here, this is the important one, scan and copy project. Here I can specify which directories should be included, which files should be included, which file extensions should be included. Should I use the git ignore to actually use that as a way to filter the files? Because what I'm doing here is that I have a feature where I can say, copy the full project in the prompt. Full project, because I have 200,000 tokens when I'm using Sonnet 3.5. So the full project, and then I'll ask questions to do refactoring and so on, right? And that's where the magic then happens. Not when you just ask a simple question. No, when you give the full project and you ask questions, that's where the magic happens. So that's what I can do. So here I can, for example, depending on the model I'm using, so let's say I'm using Anthropic here, then it will give me all the models that are available. So here's Sonnet 3.5. It even says, okay, this has 200,000 tokens. It will cost me $0.6 to send 200,000 tokens. $0.6, I mean, come on. If you have a good senior consultant that's going to cost me 800 to 1,000 euros a day, right? I will not get the output from that person. That's why I'm saying people using AI will replace people who do not use AI. That's seriously, right? So if this consultant is smart, he or she is using already this model, right? And so here I can say add the full project. And what it does, it says, okay, this project is 100,000 tokens. And it actually has copied the full project in the clipboard already. So if I go to text, edit, Let's do that one. Here it is. So I have the full project here, and it even includes the, let me show you the file, the project structure. There it is. So it tells how the project structure is actually configured. So it knows the relationships between the different classes, right? So then I can actually, once I have that there, I can actually say, give me the top 10 refactorings for this project. And I'm deliberately mistyping because it doesn't care about typos. It knows about the context, so it can actually answer that. Right? So it has the full project. This is going to take about 10 seconds or so. If, again, the internet works. If Claude is not failing, because sometimes they have too many requests, that's okay. Then I can switch and go to ChatGPT, or I can go to some, because I can have all these different models, right? So it's glowing. This blue means it's busy, it's thinking. I'm not doing any streaming, so I'm just giving the full result immediately in one go. And there it is. So it actually has responded, and it's going like, extract the service layer, blah, blah, blah. And you can start drilling down, etc. Now, what I could have done, I could have started with a local model first, which is less parameters, so it will be less smart, and then use the output from a local model, switch here. Like now I can do the reverse. I can say, go to Olama and go here to Llama 3.1. And then I could say, review this suggestion. Voila. And it has this chat memory. So it knows the response from Claude. It includes that one for the next one. And so I'm having, like, let's say I'm doing large language model orchestration between different models, between different providers. That's where, I mean, a lot of them don't do this yet. They just work with ChatGPT and that's it. Right? So here I can actually mix and match. So now I got a response from a local model, which is less smart. So I should have done it the reverse, but I just want to give you the idea how it works, right? This is how I work every day. This morning, I just developed a small project where everybody's now moving from Twitter to Blue Sky. I wanted to know how I can get the avatar from a Blue Sky account. I use this way to just, and I can just copy the code, because here it says, like, well, it's not, in this case, it's not showing any code, but if it shows code, I can just have a button there and it copies that code into my file, and that's it. I'm so much more productive. This is how you should do development. Crazy. Let's talk about this during lunch. Yeah, question?
I do have a question on security, because we're just copying code and using it in production, or production between quotes.
Yeah.
Do we have an option to review what's been produced?
Of course. Well, the thing, what it suggests is you copy what you want from what you want to use, etc.
We have to review.
Oh, yeah. You could blindly copy and hope it works, but then you have to do test-driven generation, which if I still have a bit of time, I'll show you how to do that as well. But you're still responsible. This is still, like I said, it's a stack trace, right? It's a Stack Overflow, but using AI. And you still are responsible for what you're copying. If you're copying bugs, then you're copying bugs. But if you use a good model and you give the right context, the code will be perfect.
Do you have like a specific model to actually do security updates? Where you can just drop your code and just, this is what security officer is dictating us as a company?
So I think it was last week, there was a first zero-day exploit found by DeepMind by an LLM, which was a first. It has never happened. So more and more, like Snyk, for example, is a very good one. I mean, Snyk has to use large language models, because if you give it the full context, it will know if there are bug security flaws or not. So you can definitely use that as a way to validate, for sure, 100%. But let's talk about that over a beer. Let me first go to the other slides. So DevOps Genie, I was like, well, good project. I mean, I'm using it. I've built it for myself, and it's open source. Other people can use it, fine. But I'm using it as long as AI Assistant is not free and it doesn't support everything I want. And we now got 5,000 downloads, lots of stars, which is great. I've already done the demo. And so I demonstrated this last month at Devoxx Belgium. And then there was Dominic Dorn. He comes, I don't know him personally, but he comes to Devoxx a lot. He said, tried out Devoxx Genie on my M3 Max, just pulled Llama 3.2, 132,000 tokens window, works reasonable fast, and F something, I don't know what that is. This thing is amazing. He says, I just uploaded the whole code base of one of our services and asked it to create a proper README, done in 8 seconds, local only. and that's just the README, right? He didn't even do coding yet, which is where the fun starts. So this stuff really works. Now, the cool thing is, I actually tweeted this morning. Yesterday, JetBrains announced the latest version of IntelliJ, and what's a surprise? Yes, they start supporting different models. So we can now actually support, they now support already Google, they now support ChatGPT, which they already did, but they didn't explicitly say they were using ChatGPT behind the scenes. Now they do. They support Gemini, and they support Ollama now as well. So that's a start. That's a start. But they didn't support Claude Sonnet 3.5, which is the best one. So like, come on, guys. Seriously, why not? So I'm waiting for that. But the pressure is mounting, and they are delivering, but it's still $8. And it's like, why $8? So it should be free. If I provide my API key, I can at least, but we're getting there. So I will probably drop Devoxx Genie at a certain point in time when they've catched up. But as long as they don't, then yeah, we need to look at other opportunities. And that's the beauty of having your own plugin. You can start doing some R&D and some crazy R&D. And this is the last part of my talk. It's basically, so how can I do the full Java spectrum? Now, the cool thing about what's happening with the Java language is that we've got Panama, for example, the 9th iteration of Vector API, which allows us to do matrix multiplications. Now, matrix multiplications is actually a very important part. It's where 95% of the inference happens, because it's basically doing matrix multiplications. So the Vector API is already helping on that level. But what we really need, and I'm pushing, is we need GPU support. If you're a gamer, you know vector multiplications will happen on GPUs, NVIDIA, etc., and that's where the fun starts. The problem is Java doesn't have a solution, a real standard solution yet. There is a few players. The most important one is Tornado VM. So Tornado VM has a solution to do this. I'm actually working with them together to actually start experimenting and see if we can do inference on GPU for the plugin using Llama 3. But there's also like the new version of JNI, which is the foreign function memories, which are using as well to copy chunk of data in native code, etc. So there's actually, the pieces are there of the big puzzle, but the puzzle has not yet been made. That's the point I want to make. And so there are two very interesting projects that you should have a look at, which I will demonstrate, which is called JLlama and Llama 3.java. These are two Java projects which actually are full Java inference solutions. And of course, that's the beauty of doing a DevOps event. I invite these people to DevOps to talk about this, right? So Jake, I've never met him in person, but I chatted with Jake for quite a while. I mean, last year I was building my own vector database out of just doing a proof of concept and a bit of R&D. And then I saw his implementation of JVector and I was like, bloody hell, okay, I'll stop. Because I looked at his code, it was just poetry, and mine was like, yeah, a column text. Yeah, it wasn't compared. So I stopped. What he did is just really beautiful. And the QR code is actually the link to his talk from Devoxx Belgium. But you can actually include his library, and he allows you to do Java inference within your Java code. So this is the line, generate is the inference call, where he's actually talking to an LLM locally on a Java, in the Java application. It's very straightforward. He uses, of course, JBang, which is also from Red Hat, from Max, a great project. And it's very straightforward. So you basically download JBang, you do JBang app install force JLlama at Jake, and then you start JLlama with the REST API parameter and the model you want to use, which is this one here. If that model isn't yet available, it will auto-download the model for you. But once you do that, you have a local inference, fully Java implementation running on your machine. Let me demonstrate that. So if I go to one of my projects, here it is. Let's do this one. And yeah, there it is. I've got that one ready. So I start JLlama here. It's a Spring Boot application. And now here I go and select JLlama. And I say, tell a joke. So it's now talking to the local model, and it gave an error, which is interesting. Let me see. It might be that I have some prompt exceeds. Yeah. The reason is I have to start a new one because it had the window conversation. So it's sending everything to it, which it's a bit too much for that local model because I'm using a tiny model as you saw at the start. So let's do that again. Let's see if it recovers. Otherwise, I will have to restart it. Tell a joke. One. Scroll down. No, so I will have to restart it. It's still experimental things. This is not yet ready for production, but it's getting there. There it is. I think that's going to. No, it doesn't like it. Anyway, I'll show it during a bit later on, but it does talk to it. The beauty of having this local Java version is that I can actually debug it. So I can actually debug until the matrix multiplication. So if you want to understand how attention works, you actually can go through the code and it will talk and show you how it all does this magic, how it tokenizes, how it actually does the inference, etc. So check that out. Cool. So that's one. The other one I wanted to just quickly highlight is this talk by Alfonso Petersen and Alina Jurenko. Alfonso, I mean, this guy, he works for the Oracle Labs in Zurich, and he works in the Graal team, the Graal VM team. So he knows a bit about Graal and native, etc. So very interesting person. And he basically developed one Java file. So it's called llama 3.java. It's one file. And it does full inference. They even did a native version because, well, he works for the Graal team, so you expect he can do native. But it only worked on Linux and Windows. It doesn't work on Windows yet, which I'm a Mac user, so it's like, damn, man, I need this. And so technically it's possible, but we're going to have to wait a couple of months before they actually enable certain features that we need for this. Look at this, that's the QR code. But there he demonstrated the full llama 3. Java in full Java, and they are getting to better performance than llama CPP. So remember llama CPP, the Swiss Army knife? At certain moments, they were running faster than the llama CPP version for inference. And this is full Java, but it's native, right? So it's native code, but it started in Java. So it's like, yes, I mean, Java's back in the game for AI. That's good, right? So we can make it. It works fast for very big models as well. So it works better for bigger models than for smaller models, as you can see from the graph. So that's very promising. Unfortunately, he doesn't support a REST interface, so I just built, well, I just built the REST interface. No, I just added the full project in the window context. I just talk to Sonnet and say, hey, create me a REST interface, and it creates a REST interface, and I've built the REST interface, right? Because I did the prompt, it's my code now. And that works, so I can just talk to a local version using that. I'll over a beer, I can show that because I think Murphy, or what is it? The demo gods are not with me now. And I need to move up a bit because I talk too long. So what are the LLM opportunities? There's quite a few. The first one is that the question you should say is, but Stephan, I want to run a 405 billion parameter at home. Is that possible? Because, hey, I don't like those 9 billions. I want the 405 billion, the full Monty. The answer is, yes, you can. You can. This is called, the technique they're doing is sharding. You know database sharding? Everybody knows this, right? You chunk the database in portions based on first letters or whatever. They do this now with models. Because models are, like I said, it's a neural model, so it has layers. So what you can do is say, those 5 layers will run on this machine, the next 10 layers will run on this bigger server, and the last 5 layers will work on that server. And they are interconnected. And both JLlama supports that, but there's some other cool projects which I'll quickly talk about later on as well. So sharding, yes, you can. And the beauty is you have to buy more M4 MacBooks. You know, there's this MacBook Mini I've seen. Seriously, people are, what is it, 700 euros? You can have like a cluster of Mac Minis. We used to do Raspberry Pi clusters. Now we can do Mac Mini clusters, like 10 of them, and have a 405 billion running at home for 7,000 euros. I mean, honey, come on, 7,000, you know, it's that of a new car. That's okay. Then GPU support, that's a very important one. More importantly, what you need to know with Babylon. So Babylon is the Oracle initiative to actually introduce GPU on multiple levels. The guys from Tornado have already done this with Llama 2.0, And this is a very interesting article, once you have the slides, that you should look at, which explains how to do that. And then the other one is prompt and token caching. So there's some opportunities to actually do caching of the prompts of the tokens to get faster responses as well. So there are some opportunities. There are some non-Llama opportunities as well. I could talk about this for hours, but I probably have to stop in a few minutes. But like one thing that Microsoft released is bitnets. What the hell is bitnets? Well, you would expect bits 1, 0. So, okay, quantization on 1, 0, and -1. So it's not doing floats 16, 32-bit. No, it's just reduced it to 1, 0, and -1 to represent the vector. So as a result, if I only need 3 values, I can have bigger models running locally. And what it seems is that what they've done is that the bigger the models, so the bigger the parameters, the better it works. So that's bitnet from Microsoft. You should have a look at. Layer skip is where it skips layers. So it just says, I don't need all 40 layers of the neurons, of the model. I'll just skip some layers and see if it still comes up with some good results. And it actually does. So these are R&D things which are happening, which are very interesting. And the last one is ternary matrices multiplications. So if matrix multiplications is the bottleneck, is there a solution to not do matrix multiplication? And it seems there is a technique called ternary multiplications. So I'll quickly talk about this. But what about native Java interference? So Alina told me we can't yet do that for Mac, so we're still blocked. I talked with Alfonso about this as well. I'm actually most likely doing a similar talk with him at Fox Day CERN in January. But also the Spring people saying, it's going too fast, it's going too fast. We don't yet support AOT and ASM, it's work in progress. So to have a Spring Boot native inference using Llama 3, it's going to take us still, hopefully for Christmas, who knows, but I'm not saying which year. So we're not there yet. So LLM sharding, quickly, there was this very interesting talk at DevOps Belgium by Mohamed. What they've done is that they've started in Python. It's called EXO. You should really look at it, download it. It's an open source project, but they're starting to leverage MLX, and MLX is a native library from Apple to do matrix multiplications on the metal GPU, TPU, or whatever you want to call it these days, of your Apple silicon. So they're getting very good performance for inference, and they're doing sharding. So this is an example from my home setup where I have my MacBook Pro, this one. I have a Mac Studio, which is my desktop with a bit more memory, and I just have a Mac Mini. And so I create this, I start the Python apps, but actually they're now moving towards Rust or Go. They're moving away from Python, the EXO implementation. But I now have my cluster, and then with Devoxx Genie, I just say to which endpoint it needs to talk, and the endpoint behind the scenes, they will just say, okay, well, you can see it here, the layers they're doing. So it actually says, okay, I have so much memory, so much CPU, so I'll do that many layers. And that one says, a bit smaller, I will only do those layers. And it's basically doing sharding for inference. Very interesting. And Jake does the same thing with his JLlama implementation. He not only does sharding on layer, he even does sharding on attention heads. And you can do both as well. Don't ask me how it's done. I have no idea how it's done, right? I'm just repeating what he mentioned, but seriously, if you look at the code, you go, okay, well, thanks, Jake, you're doing this for us. Just give me an interface I'll talk to, and I don't need to know the details. I will not bore you how to set this up, but you can. And then the Matmule problem. So we have Babylon. It's going to take a couple of years before we have it. We have Tornado VM today. We really want to have CUDA, but CUDA is only NVIDIA, so we don't have that on Mac. So maybe we can do this Matmule free LM, I call it, which basically it's doing a ternary expression. Again, look at the documents. I'll just believe them how they do it, but they're not doing matrix multiplications to do LM inference. The math is too difficult for me. What's the time? Because I'm almost wrapping up. How much time do I still have? Because I want to do one last demo. How many?
15? Yeah, we're 15 minutes in delay, right? So you have 15 minutes.
Oh, great, 15. So, well, I'm almost finishing, so I don't need 15. But one last point. Before I do that, any questions up to now? That's the good thing. Well, the good thing is We're here all evening, right? I'll be here all evening. Let's talk tech. Let's talk. I can't talk about this with my wife. So, I mean, please come to me and talk to me. Yeah. There was this talk at Devoxx Belgium by Booker Nieuwhuis, and he had a talk about test-driven development using generative AI. And the problem with Devoxx Belgium, if you organize it, I run around like a headless chicken from one fire to the other, making sure that the boat doesn't sink, right? I often can't go to many talks. So I missed that talk, of course, at Devoxx Belgium. You organize a party and you can't really dance on your own party. That's a bit how it feels, right? That's why I go to other events. So I went to JFOL last week, a great community event, and he did the same talk there. So I went to his session, and what he did was a very interesting approach. So he actually said he loves who does test-driven development? 3 people, 4 people. Okay, I don't do test-driven development either, right? I'm already happy that I have some tests. I'm just honest, right? Because I'm doing research and development, prototypes. Prototypes don't need tests. It's a prototype. That's why it's called a prototype, right? But his approach is, I'll first write the tests, and then I will implement. That's test-driven development, but using Gen AI. That's an interesting idea. And so he demonstrated that, and he built like this prototype, and the code worked. He didn't use LangChain4j, which is already that was already a minus point. I'll tell him this. Tom, if you see him, you can tell him. He should have used LangChain4j because he was doing his own things. I was like, come on, don't do that. Use an API, it's already there. But what he was doing, he was generating code by using a Gen AI. So Gen AI was creating the code, running the tests to see if the implementation was passing the test or not. If it wasn't passing, he could say, oh, okay, don't use this model anymore, the local one. Go to a cloud model one, which is more powerful, and now create a code which the cloud model supports, I suggest. And then all of a sudden it corrected. It said, yeah, unit test works. So, wow. So this is felt like Microsoft auto-healing software where it generates code based on your unit tests. So the better your unit tests, the better the code it generated. Right. So I was driving back home. Now I was taking the train back home. I thought, damn, that's interesting. I want to do this with Devoxx Genie because I have this plugin. I might as well try that. And that's what I did. So on the train back, it was like 5 hours. I had a working prototype when I reached Bruges, which is my hometown. And that's what I want to wrap up with just a quick demo. Hopefully that will work. We'll see. So that's part of his demonstration. So it has this unit test here. Odd even test, where it basically tests a value if it's even or odd. Yeah, and so that's the unit test. And so if I run the unit test, it fails because there's no implementation, right? I run it, and it will just fail. So there's nothing there. If you look in Java, it's empty. And so what I'm now doing here I have my own shortcode called test-driven generation. Here on the bottom, TDG, and I run it. But I'm running it with Claude Haiku 3.5, which is fine. Let's see what that one does. And it says, okay, so if it has taken, by default, it takes the window which is open as context. That's why I didn't have to do any add. It just takes that current file and says, yeah, based on the context in this case, here's a complete Java implementation of the odd-even class. And I've added this button here, create class, which you can see. So if I click on that, it adds that text, that code in IntelliJ, it adds it in the right directory. So if I go back to odd-even test and run it, green. Bloody hell, I'm out of a job. No, but seriously, so this is just a prototype, right? Well, it's a prototype with tests because it's creating the code. So that's pretty interesting. So yeah, I was really happy that worked. That's a simple example. I mean, but he did some examples with Spring Boot and so on, but it's open source. Look at my branch. If you want to extend it, PRs are welcome. More than happy to have your code. I think it's exciting times. You can see it from me. This is not an act, even if it feels a bit like a stand-up comedy type of environment here. But this is not I am enthusiastic about it because I am enthusiastic, because I know what the potential is and so on. It's exciting times, but you have to join it. If you don't join it, you're going to be replaced by somebody who is using this, which will be more productive. So I thank you for your attention. I'm here all evening. Let's do the Q&A after this over a beer and so on. And let's talk about this later on. Thank you.
Then for the second session, we'll talk about DevOps with Thomas Petit, cloud architect, and Glenn Janssens, a DevOps engineer.
It's going to be DevOps, but not the kind of DevOps that I've been seeing actually the past years. It's going to be the DevOps part. So don't think about the whole agile stuff. Don't think about the whole PM kind of stuff. We're going to go on a small journey on where we come from a development point of view, where we're heading to with the present, and of course, what should we maybe take away when tomorrow we're going to tackle the challenges that we see as developers, infrastructure engineers, and everything around it when we do so. For people knowing this logo is just the Jackass logo. Maybe this talk is a bit of a Jackass talk, but okay. We just went away. There's going to be a lot of, let's say, satirical quotes in there, statements maybe that are not fully politically correct, or maybe you feel a bit offended. It's not really the goal. If you feel offended, maybe there's something wrong. You should consider doing it differently. That being said, it's just thinking about where we are basically coming from and what we can maybe do with that new knowledge that we have to do it better. There's a lot of generated stuff in there, so I don't need to tell you that some things are just automatically generated. Hopefully, again, don't look at the words, right? Because if you generate images, I think everybody knows that there's just gibberish in the names that are spitted out. So what are we going to talk about? And then I think the easiest way to do this kind of satirical talk is just to talk about the past, the present, the future. So that's basically the three things that you'll see here, right? When talking about past, I always think about Back to the Future. I love those movies, so that's why you see the posters. So again, here we go. What's the talk about? Not so long ago, it's at least something I can't relate to because I wasn't born yet in that time. We had the 60s. Yeah, there is going to be two people apparently, I think, going to be offended maybe in the public. If I say something wrong, anything, interrupt me because, again, not my era, but I think it's Tim, the two Tim Square, right? That is going to be in the public here, right? That have maybe some experience in things that I say, so please correct me if I'm wrong. So in the 60s, 70s, we had some interesting changes actually going on in what we today would call development. And that is that, of course, we had the big mainframe era, right? We had the IBMs coming in, filling a room, maybe even filling a building, where they would plan all these machines. Pretty cool because it also introduced some kind of low-level programming languages, if I can say. And it was very monolithic, right? Monolithic in the sense that the fact that we just filled building with it was just a statement on its own. And of course, when talking about developers today, I don't know if the term developers actually ignited in that era. I would rather see them as mathematicians, maybe, right? They would go to these rooms, they would bring in these punch cards. Again, these are relatives of mine talking about these stories, bring the punch cards. They would get a slot to bring in the punch card, bring it in. They made an error, they had to go back, review it. Then, of course, they just put a patch over the small thing that they dotted in. They went back the day after. That's how they did the first kind of calculations and so forth. Of course, the 70s brought away those punch cards. We were really entering data, and that's where it lifted off. And at that time, when we look from a development point of view, was centralized infrastructure, basically, right? You had to go physically to a place, but also IT was actually utility, was something that aided you in some critical processes to do mathematical calculations, for example, and it was not competitive at all, right? It was competitive in the sense maybe that there were only one or two big mainframe companies, but I think we all know them, right? Don't need to call IBM on here, but yeah. So anywho, 60s, 70s, going a bit quicker here. In the 80s, that's already coming up a bit more towards my territory. I was born in that era, basically. So I wasn't known with the evolutions at that time, but you had the personal computer coming in. So personal computer bringing that compute power basically into your room. That was innovative in certain ways, and the most innovative way was basically you were able to do things locally, to test things, but we didn't have those network capabilities yet, right? So what happened in that time also when we project that ID, or let's say the change in compute, we actually saw businesses giving these kind of PCs to departments. You would get these scattered kind of inconsistent implementation because each department would get their set of computers or one computer to just do their thing with, right? So that's also the moment where we see actually that the departments were actually owning the systems and starting to first maintain kind of systems in that ecosystem, but it was hugely inconsistent. When I look back on the 80s, I always think about these publicities where they, first of all, used Excel. It's the first really version of Excel in an elevator. I think it's a Microsoft pitch there, where they were able to show, look, my department was able to basically do a small calculation on a computer to give a financial statistic towards my board. Interesting time, but it was also a time where compilers, we talk about C, I heard it before, C, C++. Well, that's the era where these first things started to hang on, right? And C and C++, I mean, I think everybody here either knows it or has used it, right? And we heard the talk before, still C++, hugely popular and powerful. 90s, that definitely should, I think, with Tim and other colleagues, that there's definitely some experience in here where the first steps in the 90s using the client-server model were explored. And what did we see in that era? And that's the most interesting part for me, is that first of all, the developers were able to use access to databases. So we were able to actually use databases in a context as developers to actually even do it multi-tiered, right? So we had developers maybe managing more the applications and accessing the database, but you also had the upcoming infrastructure teams managing those databases, managing the underlying infrastructure. And rather than having one PC per department, we actually saw a shift in the 90s where the actual departments were centralizing a lot of stuff, right? So it was not a PC per department anymore. It was centralized infrastructure, teams managing that infrastructure, and developers being able to slowly, in a multi-tiered model, exploit that. On the image that you have here, I took that purposely. You see an IIS server. When talking with the Azure guys, of course, when talking IIS, they still say, yeah, the good old IIS. So that's why, I don't know why, but I wanted to have that image on there. So again, at that time, and I think from a business point of view, and that's also what I like to take away here, is that 90s was a bit like a strategic enabler. So when you invested in that kind of technology, it was seen as a strategic enabler for companies, right? It was targeted at growth, and there was some kind of model to find here, where the fact that you were able to tier the kind of model, serve new kind of services towards the external people was really interesting. So what you also see on this image with the client server database that you have here, right? Multi-tiering. Then the 2000s, that should already come up more to everyone's alley, I think, or at least what I see is this is the kind of stuff that I've still, let's say, seen and within an enterprise context, because I came in touch with it. Maybe not the newest developments, the first developments, but at least I saw maintenance stuff coming towards my way when I started my professional career. And that's the era where you actually had the enterprise middleware. When I talk about enterprise middleware, I don't know why, but I always think about ESBs, but of course ESBs is just a small part of the middleware stuff. There's definitely GEE that we know. And the thing that you have here, WebLogic, WebSphere, I don't know if people know that kind of technology still. Yeah. Resource hungry a lot, configuration heavy, love it. Yeah, there was a lot of work in just maintaining those stuff, right? And that's also the era of where you see that actually we were maturing. That model of the tiered model was actually maturing out, and developers were actually getting more tools in their hand to actually use that kind of stuff. They had these dependencies that they suddenly needed to manage, large frameworks. That's what you see on the left on this image. And of course, applications became more complex, way more complex. The fact is that while the applications became more complex, also the underlying application service became more complex. And that's what we see on the WebLogic and the WebSphere part. But of course, here in that era, it's interesting to know also that companies were actually shifting away from the fact that IT as just a thing you should maybe do, is that this is a central part of your investment as a company. Suddenly there in that era, 2000 was no debate anymore. 2000 was an era where you needed to do some things with IT, and in this case, enterprise middleware to do your business, right? So that's an interesting shift that we already see here also. And of course, it became more complex, became, let's say, more difficult to maintain. That's also what I saw, because it's more towards the end of that era where I first came in contact with a lot of these things. You saw a lot of maintenance. Maybe it was just edging already off, but I often got into projects where I just needed to do it with that one WebLogic still floating around that needed to be migrated, but nobody dared to touch it. That's basically the kind of that's experience that I had with that technology. Now, the interesting thing is that I put the words here like Mule ESB. It's not MuleSoft, it's the predecessor of this, right? The concept of ESB, the fact of centralizing these connectors, these integrations. There was some interesting thought already in there. And we'll see later on where that maybe that idea already pops up again in a different kind of form, right? There's a small intermezzo that I'd like to take before jumping immediately 10, and then, of course, going to the AI stuff. But the 2001 was the year of Agile. And I often like to refer to it, and maybe people hate me for it, but was the idea of Agile where it was still pure, right? The idea where it focused on iteratively, customer centricity. I mean, all spoke words because we came from a enterprise middleware layer where there were things becoming more complex, and suddenly there was the idea to bring that closer back to business. And we also saw a shift when you see the articles in that time. There was a brief moment, at least from what I could read and the books that I've read there, is that there was a brief moment where business actually embraced, together with IT, the people working, that it should be something that embraces end to end, and not like we maybe see today, some kind of certification program that you should do to do your work better, right? So for a brief moment, we saw that change being introduced, and there's also that cultural shift that we have in that era, right? 2001 already introduced that, and I mean, there's really some good thoughts in what's going on. Interestingly, there were some gaps within Agile, and gaps where basically we talked about faster, more iteratively, but it was still a bit disconnected with the operation part, right? How are we going to actually do it more iteratively while also bringing that idea to the operation side? So there was disconnect also with infrastructure at that time. So in 2008, that's the time that we actually see DevOps, the idea of DevOps picking up, fixing let's say, filling in the blanks is maybe the better word of what Agile left behind, and also giving developers more control over the operational stuff, being able to deploy yourself, that idea of being able for you as a developer to push on a button, push on a pipeline, and see the code going live, rather than talking to that infrastructure guy sitting over there and then please deploy that artifact for me. That was already a mind shift, a really nice one. Yeah. So DevOps was born basically, and that's what I wrote down or remembered for myself as a way of actually fixing a couple of blind spots that we created during the Agile mind shift. And of course, when talking DevOps, we actually refer to, again, more the part where we want to streamline the operations. So it's also talking about CI/CD, standards IT processes, where we want to control the way we work with code, the way we build code and deploy code, right? To integrate that seamlessly. And again, now we have that evolution, bringing everything more closer, right? We're be able to streamline stuff, or at least that's what we can see towards the history. You can also see that trend now that we optimized the way of deploying, integrating. You can see the ID. I think it in 2014 that I saw the article of Martin Fowler. It was an ID where microservices, the thing, I think there was a mind map later, still a hot topic. I mean, it's 2014, the ID was pinned like microservices. Interesting ID to solve more complex problems where we want to have flexibility. So there were specific use cases even highlighted in that. And still 10 years later, that topic pops up as an interesting one. I see it on each conference. But the idea was actually born, and you can see that it was more an evolution, made logical sense. Now that we fixed a couple of issues, the monolithic part was getting better under control. We had the idea popping up microservices, right? Being able to push towards more modular infrastructure. That's definitely a thing that we saw. And of course, Spring Boot, also a framework. We of course now have Quarkus around also in that ecosystem. But the ethos of Spring Boot, for me at least at that time, was like, yeah, now I can ditch the GBoss stuff. I can ditch the whole dependency frameworks. I just don't want to deal with that anymore. I just want to deal with code. And that was for me a revelation, like, this is the thing I want to do. Focus on code, make it minimal. Isn't it? The Spring Boot stuff is not tightly dependent on microservices, but of course it helps, because if you wanted to do microservices and you had the capability to actually make small deployable units, make also single binary artifacts, an Uber jar, that kind of idea actually was born in that era for me. Virtualization, but it'll pop up later. Yeah, indeed. Good point. So here, what we actually see in that era also is that companies in the 10s were actually focusing more on market diversification through technology. You actually see really tech companies or companies where you would maybe say these are traditional companies with a typical business model. You actually see here the tech pop-ups also popping up. So differentiating through technology and not through competing models on better pricing, new features. No. Purely on technology. Really interesting times, because we were able to actually develop faster, and the complexity, of course, and that's maybe something I would like to highlight, certainly when I hear microservices these days, which we'll pick up on later, is that the complexity actually grew, right? Suddenly you had to choose between different kind of deployment models. Is microservices still the best thing to do? Where should you use it? Should you use JBoss still? Maybe it's still interesting in some cases where you need that large compute, certain types of, let's say, requests that you need to be handling, or maybe you just need something lightweight that fits perfectly in that model. So you had to think already way more about which model to use and where to use it, right? The fact that, for me, the frameworks, GE, the GBoss, are still around says something, right? Says still something. So then, of course, I won't highlight the virtualization directly, but of course, it found place in that 10s, and then the virtualization was a key pivotal moment also towards things that we saw in containerization. Virtualization in the era before already kicked off, but when you see at containers, and then later on also micro VMs that you see popping up, I think in 2018-19 that I saw, so in the 10s there, you see that whole virtualization move, and of course containers fits in that part. So now we're not only able to make our application smaller using frameworks like Spring Boot, but we're also able to miniaturize our infrastructure using containers, and later on using micro VMs, also cool developments. So it empowered actually developers to do way more at a larger scale, way more larger scale. And we didn't only have the, let's say, the containers here, Docker, of course, being the first in that, let's say, big idea. We also saw the serverless ID popping up, right? I remember really well that I was just so happy that I had my first Lambda. I had the first version of the Alexa Echo. The only way to integrate with is using a Lambda, so it was a no-brainer, first contact, and was just cool. I can just package my code in a different way. Don't need to care about all those details. But again, choices. All kinds of choices to make. The infrastructure as code is also a thing that we saw popping up within 2010. So referring back to the WebLogic eras where you just need to click through the GUIs and then complain because it just crashed, the GUI crashed, and then you need to reboot the GUI to be able to just do your deployment, that kind of crap. Now suddenly you get tools like infrastructure as code to be even making your infrastructure and then deploying your stuff on that infrastructure. So really cool evolutions, but again, choices. You make choices, more choices. And of course, these days, when we look at companies and we're confronted with this concept, of course, in day-to-day as developers, we have these complex systems. They were already complex to maintain, and they just become more complex. Now, of course, you could say like, yeah, but public cloud fixes that for us. But have you seen the amount of services that you can just choose from? I mean, it's like these days going just to a store to get a jeans. For me, it's even just difficult to say like, I just want the same jeans with the same color. Then you get like 100 choices, right? And you had that same kind of paralysis actually on the whole stuff going on in 2010. So the agility certainly came at a cost. And I think developers for us these days, it's like even coming into discussions that we see still today, where we actually need to make choices. But we can be happy. There's a moment where we saw before where we had just a room where you got in, where that vendor, the IBM mainframe, just decided that's the way you will work. It's that way you will come with that kind of punch cards, and that's it. So we had flexibility. I think just knowing from where we came, that's a huge thing that we have here, right? And I just copied it, Jeremy. I don't know if you already patented it, but I call it the era of III. It's the era of III. I don't know where this is going yet, right? I know there's certainly good things in there. I think we had the previous talk. There's still cool things coming up. I recently talked to a developer. I came from Devoxx also. Said like, I have a cool plugin. Now I don't need to go to my Jaeger instance. I don't need to consult the tracing metrics anymore on Grafana. I will just run it on my IntelliJ, and the LLM model will just, let's say, consider all the traces coming out of it, and it will just do the performance detection from right off the bat locally. So I can check if my application will actually introduce new latencies or misbehaviors. And I was like, really, that's cool. So you actually don't need that big infrastructure, fully automated platform. You can now do it on your local machine. And actually, that's the whole reason why we put up the tracing, the metrics all there, to make it more visible by bringing it more towards your computer, by bringing it more closer to your, let's say, shift left. You were actually able to filter out those issues. So why do we need the 24/7? Every trace needs to be logged. Maybe that doesn't need to be done anymore. We can just make samples like every 5 minutes to see if the tracing is still okay, because you already did the testing up front on your local machine to see if your application misbehaved or not. So really cool stuff. But yeah, there's a steep learning curve, right? And I think we heard in the previous talk a lot about applicatively, which is really cool. Myself, I've been last 4 or 5 years more interested in the infrastructure side, so Kubernetes and everything surrounding it, and also virtualization. So for me, of course, I put here the 4 big public LLMs that you, of course, see, the public services that you probably consume, the Geminis, the ChatGPTs, the Claude, that kind of stuff. But there's also NVIDIA empowering all that stuff. It's incredible. And it's so easy just to do and to set up. I was thinking like, how difficult must it be? I need to know how the Linux kernel actually will pass through all that kind of graphic cards information. I'll need to multiplex even, because I have a simple graphics card. I can't use it and share it between different kind of containers. How difficult will it be? And actually, in a couple of days, I was just able to plug in the card, configure the Linux machine, set up the operator using an NVIDIA stuff that you have here, even multiplex it, because there was a talk where it just talked, you can just software-wise share your graphics card over different kind of containers, and just works in a couple of, let's say, days, right? Between hardware installation and this. So I think there's a huge shift where we actually are able to do things more efficiently and faster. Even just integrating it becomes easy. But of course, complexity just rises. And I think one of the things that I'm always worried about, because as a tech geek, maybe more on the lower side on infrastructure these days, but do I fully understand what these machines are actually spitting out, right? And that's always the thing that you try to do. And by the end, when you understand it, the next era is there. And then you already start with the next part, right? By the moment that you think, yes, I know how it works, either you're still in COBOL, either still or you're already in the next chapter and doing the next thing, right? So, and the other thing that I see, and I see a shift, and that's a shift in 1 year's time that I've been seeing, and then that's the graph on the left side here, it's the energy consumption. You see, of course, these specific processors being made. We also talk about security, of course, but I think there's an interesting statistic where normally in 2030, 9% of our energy consumption will go towards AI applications, AI-driven stuff, whatever, 9%. I mean, that's huge. So there will be developments on that side also. We will maybe have more developments where maybe your full computer is actually a GPU and that's it. I don't know. Really cool stuff. And probably we'll need to learn how to use that stuff too. And have a new model, not a LangChain, maybe something else, right? But anywho, that's a full encompassing story about the past.
All right. First of all,
Yeah, I don't know if the mic works.
so first of all, when I saw Thomas was making his first slide, the mainframe, I actually thought like, what are we going to tell them? Where are we gonna start? Because I'm even younger. I'm from the 90s. But actually, I must say, when he was going through the first dry run, I was actually like, okay, this is actually interesting. I've never really thought from up to there to where we are now, like what happened, what transpired, how did we really get there? That we moved away from the big mainframes, that we went to client-server model to make the process more efficient, and that we introduced both frameworks, DevOps, Agile, and containerization to make everything go smoother and deliver much quicker. So that actually was really interesting, just to have like a quick recap and to see like, okay, so we got here at the present day because of all the things that we experienced in the past. But now we are actually quite in the shit show, I think, because I've seen a couple of problems that were highlighted during those times. And I think to myself, did we actually really solve all those problems, or did we just iteratively go over each problem and solve them at that time? So yeah, I think let's go through it together and let's see if we actually solved them and if they can't really appear anymore. But before we do that, why should we actually care about that? I have a dream that one day I wake up, I start up my laptop, I go into my application that I was creating yesterday, and that actually all my builds are still running fine, that there are no false positives that suddenly popped up where a build is failing and nothing has changed. But I believe we're not there yet. There are quite some things that still have impact on them. There are quite still a lot of things that have impact on my work as a developer that I don't really have any impact on right now, and that someone has to do for me. So I'm actually quite dependent on several teams, people, and departments that need to guide me. And first of all, let's start actually with the mainframes. So did we really get rid of all the problems that mainframe solved? I'm not sure. We went to cloud providers because they offered solutions to problems that arise. They offered more scalability. They offered compute on demand and where we needed it. And we could also focus a lot on innovation. They brought more and more into that, and they followed along the latest open source and technology, and they were evolving together with us. But I feel nowadays that sometimes we need certain skill sets or certain expertise to connect all the dots that are already in there. So did we actually solve the rigid infrastructure part that was in there before? Or did we just create a new? And do we have a problem there that it's going to be ever evolving, and at a certain point we won't be able to return? A second thing that also Thomas mentioned was that the developers could focus on code, which was great. We could finally just leave everything behind and just focus on the thing that we like to do the most, focus on writing code. And what did the companies do? Well, some of them designed a central DevOps team. They learned about the DevOps culture. They learned about certain things that would really benefit them and that would really fill in all the gaps that Agile left for them. But somehow that's got all put into one team, and now developers can just throw it over the wall to the DevOps team, and the DevOps team will solve all the problems. If their code doesn't behave or doesn't work that well in production, I guess the DevOps team will solve it. I guess they'll have all the necessary tools, expertise, and skill sets to do all that, and that a developer can just focus on delivering the code and have no worries about ever doing anything else, because there's no self-service needed. We just have the team that can take care of anything, right? Another thing that we do efficiently is share information these days. We have Git, I think we all use Git, or hopefully we all use Git to do a big amount of our daily work. And it's really nice because it makes it quite easy to find bugs or issues or things that someone did wrong. And there is just a label on it with a name of the person that put it into it. So we can just blame that person for doing it wrong, or just blame that person for putting it in there. And we don't ever have to worry about finding the root cause or how we can fix it in the future. We can just point the blame to the person, and GitOps even automates that process because it automatically gets pushed to where it needs to be. And we can automatically see that the person fucked up and make him responsible to fix it. I always say automation is key. I think in the ever complexing or ever getting complexing environment that we are in, it will be difficult to do anything if you don't automate certain parts of it. Like, for instance, I'm working in a cloud provider, I'm working on premise, I have CI/CD tools, I have a lot of tools that are in there. I probably don't even know all the tools that my company is using, but automation will help me to do and work a lot around them. But I don't have to worry about my application only right now. I also have to worry about my automation, because I'll probably automate something, maybe something simple, maybe I'll write a script for something, maybe I'll create a pipeline for it. I will put it somewhere where it can run, and it will probably work fine. I'll probably never have to look at it again, and it will continue to be worth the investment that I put into it, right? Yeah, I'm not sure. I think I mostly have to maintain quite a lot of my automation that I've already invested in. So, you know, it takes time. You don't really have to really worry about investing only the time to automate it. You also have to worry about keeping it managed, keeping it maintained, making sure that it can last in things that are evolving, things that are getting more difficult, because we are putting new technologies into it, because the landscape is changing. So it's something that we have to worry about as well. And if we go a bit further into that, then we also have to improve it continuously. We have to hold endless meetings of what can be done better, of what can be improved. We have to create elaborate reports of what we have been doing in the past, where we see some gaps. We have to track a lot of metrics that show what can be done better. Like, for example, I mentioned Git. You can also see like how many lines of code a developer created. You have Sonar to deliver a lot of feedback on what we are doing. And there's so much, it's only getting more. There's only more feedback on what we have to improve. So the thing is, are we going to keep improving everything? Are we going to never look back on what we improved in the past and what we're going to do in the future? I don't know. Sometimes it's a bit hard, you know, because there's a lot to do. If it works for one team or one project, will it work for another team? We have to standardize it as well. We have to find some new approaches to get everyone on board in the standard way of working. So yeah, we continuously need to look at everything and continuously need to make sure that everything gets better, which is not that easy to do. And then, like Thomas was mentioning as well, Agile versus DevOps. DevOps was there to fill in the gaps of what Agile didn't deliver, or where Agile had a couple of missing blanks. But we feel like DevOps actually went a bit to the dark side, right? They started to not really fill in the blind spots, but like it started to mingle a bit. And I'm going to explain it a bit more better with an example. So imagine if Agile is a rebel alliance, like they move in small compartment teams. They can like create a plan efficiently. They easily gather information, and they can like quickly use that information to get into a new plan and to adapt around it. Like, let's say that they are going to take over an imperial base. They can do that very efficiently because they work that way. Another thing is they have very good collaboration and communication because they are used to work in separate teams that communicate well with their leaders, and they really involve their stakeholders to do that. But if we compare it to the Galactic Empire, if you compare it to DevOps, it's more like the Galactic Empire, but in a good way. They make sure that everything is standardized. They make sure that they can easily deploy all their star destroyers efficiently because they focus on speed. They can focus on every time creating the exact same artifact or model, and in this case, a star destroyer that will be working perfectly. It will have the right dimensions. It will work the same every time, and it won't have any bugs in it because that's already worked out. They also break down silos because, yeah, the Empire has different departments. They have stormtroopers, they have TIE fighter pilots, they have everything, but they all work together to a common goal. And that's a bit like DevOps, right? We try to break down those silos, and we try to have a collaboration between development and operations, and we try to foster that collaboration and share the responsibilities. I thought it was a cool thing, like to compare them a bit. Like, it's not, DevOps is not really evil. It's actually a way to have better standardization and a better approach to it. So I hope I could like share a bit of light on that. And then if we look at shift left, you see Thomas edited the slide a bit. I was not aware of that. Trust me. It actually really started with someone saying, "You build it, you run it." I think it is a quote from some time ago already. Like I said, I've only been working like 6 to 7 years in IT. But you build it, you run it is actually something that I think I started already hearing like during my first or second year when I was working. And for me, it didn't really mean like, okay, you now have to do it all yourself. It really meant to me like, okay, if you want to build your code, if you want to make sure it has it has, yeah, how do you say it? If it has all the right qualities of a good code, like security checks are there, the quality gates are like to a good standard. And I always thought, yeah, that's my job. I like help developers getting to there, that they can focus on the right code and that the quality is guaranteed. But for some reason over the years, I've seen it change, and I've seen developers more burdened with the responsibilities of doing it themselves, of having ownership handed to them. But what what really is that ownership. Nobody is really, nobody can really define it. It probably means that the DevOps team has too many issues to work through. So here, let's hand a bag of ownership to the developers so they can do a bunch of the things themselves, so they don't have to wait on the central DevOps team. But I don't think that's where we want to go, right? I think we just want to deliver quick feedback of the security checks, of the quality of the code, and even of what is happening in production, and that you're able to react on it, and that you can make it better. And that you can put in CI/CD, or you could do it in different ways. But I think it's necessary that the developers don't really are just pushed that ownership. It should be a collaboration. It should be something that we work on together, and where we can really like help each other in and go to where we want to go. And communication is an important part of that as well, because if we don't communicate on where we want to go, then we'll probably end up somewhere where we both don't want to be at. And I think, Thomas, you have something more to say about that, right?
Who's doing shift left, or yeah, one who's heard about GitOps? Oh yeah, fuck yeah, yeah. Yeah, I think what I've seen lately is actually these things just going bad again, right? Suddenly the GitOps, the idea of GitOps, we saw the same with Agile, we saw the same with DevOps. We just removed the first three letters, we just put something new in front of it, right? And then becomes suddenly the infrastructure guy. It's now just called Ops. Never touched any Git in his life. He knows really well how to use probably VM, Vim, the Bash. But you just say like, did you ever use Git? Well, now just use GitOps. Just going to fix your issues. I mean, I've been seeing that trend now going on. There's the FinOps stuff. I'm just not going to go in that part, but there's some interesting stuff going on. We're inventing new terms, and I sometimes need to slow down and think, wait, what are we trying to fix here, right? Did we think about things like feedback loop? How is that going to be represented in GitOps? Yeah, I don't know. That's for the ops to just figure out, right? So again, that's one of these things like we saw with the shift left, with the Agile DevOps trend, and I see the same thing going on with GitOps, and probably there will be a next ops that I will find in an article tomorrow morning or something that will just do the same mistake again. And of course, we have the term platform engineering. Love that one, right? Gave you the history, fantastic, right? Now it's just DevOps again. Right? I mean, I don't understand how we can even get in that scenario where I need to read the articles that promise me cool stuff, while in reality, I just see that idea of a team sitting there again, which is actually now rebranded as platform engineering, or even better, these are platform engineers. I don't know if it's beneficial for a rate or something. Maybe it is. But yeah, just basically there's a lot of rebranding going on. And if we take a look back in the history of times, again, what are we fixing? Are we rebranding stuff, or are we really fixing things? Because the idea was always pure in the past, right? The idea was there to progressively, iteratively fix one problem, go to the next. But I don't know if we're doing that these days. And there's also the trend going on. I've got a tool for that, right? We have these different kind of stakeholders within the company. There's a developer. There's maybe a DevOps, if you not represented as a team, but a developer actually doing some ops stuff, right? Like the real DevOps ID, pushing on the button, deploying stuff. Yeah, that still exists, I hope. But there's also the ops maybe getting involved with development, knowing what they're trying to accomplish and seeing how we can optimize the infrastructure and the automation surrounding that. And there's each time again some tools, some interactions needed to make that puzzle work, right? The whole puzzle needs to work. And what I see is that there's a tool for documenting, and I typically need to ask like, hey, are you doing it in Confluence, GitHub, with Markdown pages? Are you just using, I don't know, just straight in the code? I mean, that works for me too. Yeah, and we have a tool for that part. For diagrams, you'll need to go to Enterprise Architect. And for the other ones, you'll need to use an open API, or we'll commit it towards the API manager where you have a developer catalog. I'm like, great. So there's a bit everywhere, right? And there's a lot. So I think we fixed this, right? Yeah, I don't think so either. I see people nodding no. No, I don't think so either. I mean, I think we fixed something. We acknowledged that we want to streamline the interactions. That's definitely a good thing. But we forgot one thing, going back to the roots. Why are these tools there in the first place? Why can't I use that one tool and you use it for multiple things rather than just introducing a new one? So again, I'm a consultant, so I think for me it's interesting because yeah, there's consulting to do on that side, but maybe it's also good to go towards, let's say, the enterprise, the company, or even your manager, your peer, and discuss what's the root of the problem that we're trying to fix here. And can't we do it more simple? Yeah, there's still that sentiment for me that we're not fixing the right stuff, and thus these tools, they need to already fulfill some kind of expectations. I saw the meetings with things like Backstage, and also at Lation side, you also have, I think now, with the harnesses. There's all these kind of tools, and they need to fulfill some kind of thing that they will not fix for companies. But suddenly, I mean, developer catalogs will fix everything, right? They will not. And I think that's really important, because we did forget the primary lesson there. And of course, tooling. I had some cool talks when I come in with a kind of map on tools that we have, frameworks that developers are using to empower themselves. They're using plugins. Maybe tomorrow you use the Devoxx Genie also in that stack, right? You'll put them on a map. You'll go towards your management. We need yet another couple of tools that need to be integrated in there. And I've seen these days also tools popping up just for sake of tools, and it becomes a bit like the game that I was used to play on Schoolyard, right? Gotta catch them all. I mean, it's that sentiment that I just get. Maybe it's just retro vibes that I need to go back to those times. But again, I see that popping up in the day-to-day stuff. We're just trying to not look back, look forward, look towards the next tool that we can probably use to fix these kind of issues that are popping up, while a lot of these tools are already in front of our noses to fix these things. But it's always easier to just add one other tool, right? So again, and probably I'm bringing a bit of the shit show here. Probably I'm already guilty on a couple of these things, right? I just want to say I'm not a saint on this part. We're just learning through this, so yeah. Sorry up front for a couple of faces that I know. You'll probably say like, "Hey, but you were a part of the problem here, man." Yeah, I was. But acknowledgement is the first part. So that's a bit like, have we fixed the things that we wanted to set forth? I mean, if we look back on the history that we had previously, each time again, we had a problem, we tried to fix it. Did we fully fix it? Probably not. We saw it with Agile, with DevOps. We saw it with the actual client-server model going to enterprise middleware. We saw it going on towards more modular stuff, introducing new problems, maybe not acknowledging the old ones correctly, and adding just more to it. So I typically use that meme also on Teams chats and everything, or WhatsApp. If you see like what kind of fit show is that, I always think about Jurassic Park, where you had that quote of Jeff Goldblum just saying like, "That's a big pile of shit, man." So again, maybe I'm just too cynical as an architect, but that's the thing I remember. Want me to go on, or you'll go?
Feels like we're suddenly in the AA. Acknowledgement is the first. Okay. So, last part, we're gonna keep it short. We're just gonna have 3 takeaways. We've seen a lot of the shit show. We've seen how large actually the big pile of shit is, but we just want to give you like 3 IDs, 3 tips that we can give you, so that we can maybe make the shit show, maybe downsize it a bit, maybe like fix a couple of things, who knows. Something that's stuck by me for a long time now is a talk that was at DevOps World, I think last year or the year before, and it's a talk that some of my colleagues saw, and they came back and they were like, there is this second biggest Dutch German bank, yeah, and they said, we're focusing on 10 tools and we're trying to maximize the output that we get with those 10 tools, and we try to also stick to those 10 tools. And I think if you search for it, you can probably find the exact 10 tools that they used. It was really cool to see that they were actually focusing on only 10 tools and seeing to maximize them throughout their department. Like, if I want to give an example, another thing that I saw or heard some time ago was a company that threw out Confluence and they moved everything to GitHub. So they were like moved everything to Markdown. They used generators, so purely for documentation, right? And they just made everything accessible through GitHub. They created pages. They made sure their analysts, their business could use it, and that they didn't really have to learn anything about GitHub, or not that much, and that they can just use it as their main documentation platform. And you see other things that you can do, like with, for example, GitHub, where you can just centralize a bunch of the things and a bunch of the capabilities that they offer. And if you're also just be a bit creative, you might be able to solve some of your problems that a secondary tool will solve as well. So there's just a lot that you can do, which is focusing on what there is already there, focusing on a skill set that is maybe very a skill set that is very high in your organization. Like, let's, for example, Java. If you have like a really great expertise in your company of Java, maybe you don't have to use, let's say, Ansible to do configuration as code, or you don't need any other tool. Maybe you can just create a Java application with the Genie and say like, hey, we want to do some configuration as code. I'm just spitballing a bit here, but you know, like, if you be a bit creative, maybe you don't have to adopt some random tool to solve a problem that you have. It's something to take into account, right? It can be a bit of a mantra. Just think about this first and then look at another tool. I also like Back to the Future. I also immediately thought about adding it to the slides. I think we can all agree, or hopefully we can all agree, there is no such thing as future-proof. We have to keep evolving. We have to keep in mind of what the problems and challenges are that we want to solve and how we can solve them, and that we don't really look at one technology as being everlasting and still solving all our problems throughout the future, because we probably don't really know all the problems and challenges that will arrive soon. AI will probably be able to solve some new challenges and new problems, but maybe it will also create some new challenges and problems that we will need to solve in the future. So keep in mind, just take a couple of seconds when a new challenge arises, think about it, analyze it. Hopefully, the company where it arises gives you the time and needs and tools to take a look at it. Because sometimes, sadly, we have to go fast and it all needs to get done rather quickly. It's just something to also be mindful of. And then the last thing, and I think everyone here came to this meeting to indulge in the last tip. Exchange problems and share ideas. Go to communities, check in with your stakeholders, check in with colleagues, with friends that work in the same area, or maybe even not in the same area, that can like pivot your ideas, and like maybe you hear them telling something new that works in their area, and maybe you can take it with you. But yeah, I feel like there is a lot of sharing ideas and sharing use cases, sharing problems, and how someone solved a problem or solved a a certain challenge that they had at their company, or even solved new things that they were able to solve with AI. It's really interesting just to go to these communities and like have a talk with people you don't know and like see like how they think, how they visualize certain problems, and yeah, we can all learn from each other. I think that's the most important part I really wanted to share with this last slide. And that is it. Hopefully we can have a nice chat right now, drink some beer, have some pizza, and get to know each other.
Ha ha ha.